PDE format, right? But anyway, no problem. If you have Virarajan book, you can buy Virarajan book, or we have Kandasamy book, and then Balaji book also there. So for me, book is not at all a problem. You can follow any book, right? So for me, for online classes, this is the book available in Kindle, Amazon, so that I can teach you, right, through this e-resources, right? So but one thing is there, right? You have to attend the class properly, right? And you can take problems from any book and you can work it out, right? That is the only thing I expect from you, right? So I just recall whatever we discussed last class, right? I told the basic natural number system is the number system starting from 1, 2, 3, and so on, right? So this is the basic natural number system. So this is natural 1, 2, 3, 4, 5, 6 up to infinity, right? And then next one is 0, 1, 2, dot, dot, dot up to infinity. This is whole number system, right? And the next one is the integers. So integers means that is minus 2, comma, minus 1, 0, 1, 2, so on. So numbers from minus infinity to plus infinity, these numbers are called as integers. And then fractionals. Fractionals of the form 1 by 2, comma, 3 by 4. All these things are all rational numbers. And there are some numbers, right, which cannot be written in terms of a by b, right? For example, the pi value. What is pi? Pi value roughly say it is 3.14, or we simply say it is equals to 22 by 7. But remember, pi is not a rational number, pi is a irrational number. So whatever the things here, 3.14 or 22 by 7 are all approximation, rational approximation of the irrational number. So what is the difference between rational number and irrational number? In rational number, we can write that number in the form of a by b. Suppose 1 by 3. If it's 1 by 3, it is 0.3333. Even though it is keep on going 0.333, but still we know what is the pattern of the number. What is the pattern of the number? But numbers like pi, right? It is 3.14 and it is keep on going. And there is no pattern, there is no ending for that type of number. So this type of numbers are called as irrational numbers, right? Then the union of, right? Remember the union of rational, rational and irrational numbers. These two things, right, takes you to the real number system. These two things takes you to the real number system. These two things to the real number system. So what is a real number system, right? What is a real number system? Right. What is real number system? Do you know that graphs you draw, right? Whenever you are in the schools, right? You have x-axis and you have y-axis, right? So when x-axis and y-axis, or y-axis also called as f of x, right? So here when you see this number system, right? So here you are writing 0, you are writing 1, and you are writing 2, and so on. But originally, right, there are infinite numbers are there in between 0 to 1, right? So that in the last class itself I explained, right? You can't tell, right? So whatever the line, this line you are drawing, right? This line is called as x-axis, right? Otherwise, this line is also called as real line. Why it is called real line? Because it consists the real number system. What is a real number system? It is a union of rational and irrational, right? What is the importance about real number system? It has no gaps. It has no gaps. No gaps means you can't find a gap between two real numbers, right? For example, what is the real number after 0? somebody sell 0.01. No, it is not that, because 0.01 is sliced between 0 and 0.1. So if you keep on going like this, we can't find a number, any number, right? And the successive number means the next real number of that number. Practically it is not possible, right? So we can't simply tell minus infinity and plus infinity are very huge big numbers, not like that. Even in between 0 to 1, even in between 0 to 1, there are Humpty numbers are there, right? So now these numbers are continuous in nature, because remember, when you say only real numbers, whole numbers, it is only 1, 2, 3. So there is a gap between 1 and 2, like 1.5, right? But in real number system, there is no gap. Numbers are moving without any gap, right? From that only the limit concept arises. So in your schools, you studied this, limit extends to 2 of x square. Right? So last class, so those who are in the last class, tell me what is the value of this? Surya, Syed, tell me what is the value of this?
4.
4. How we are telling it is 4?
1.999 is equal to 3.99.
Right. So limit concept you have to use. We should not simply substitute x equal to 2 and this is 2 square 4. Not like that. Right? It is limit concept. Limit concept means x approaches the number 2. So when x approaches the number 2, the function, this is the function, f of x function. Right? This is the function. Right? Function you can draw like this. This is f of x, you can draw like this. So when x-axis, right, if x value approaches to what the y value approaches, so then you have to put a number nearer to 2, something like 1.999 in the left hand side of 2. Similarly 2.001 in the right side of 2. When you put these numbers to the function, right, you will get, when you put x equal to 1.999, you will get x square is 3.999 something, which is nearer to 4. Similarly, when you put x equals to 2.001 in the function, because function is defined as x square, then you get 0.4.001 you are getting. So these two numbers are nearer to 4. So what is the meaning? When x approaches 2, the function f of x approaches 4. And this value is called as the limit value. This value is called as the limit value of the function. Then what is the function value? Function value means directly you have to substitute that value in the function itself and you have to find that value. So when you put x is equals to 2 directly, right, here, then you will get 4. So this is called function value. So this is called limit values. You should understand the difference between limit concept. So limit concept is not exactly function value. It only says what the value f of x approaches when x approaches at a number. So here when x approaches 2, f of x approaches 4. So that is called limit value. But this is called function value, right? Directly you have put x equal to 2 directly and you are finding x equals to 4. So if the limit value is equals to the function value, then only we call the function is a continuous function. So this is an example for a continuous function, because in this function the limit value also 4, the function value also 4. So this is an example for a continuous function. Then you may ask, sir, when limit value doesn't equals to function value, right? Further I will give you an example. Last class itself I gave, but anyway just I recollect. If you define a function like this, f of x equals to x square when x not equals to 2 and it's equals to 5 when x equals to 2, right? So if you see this function, the graph of the function is like this. It goes like this. It also looks like a parabola, right? But at the point x equals to 2, the function doesn't follow x square. It follows 5 value, right? So at x is equals to 2, exactly at x equals to 2, the function value jumps to 5. The function value, this is y value jumps to 5. So this function travels like this, x square, x square, x square, x square. But suddenly at the point x equal to 2, it jumps to the value 5. Then from the next number onwards, it follows x square path. Here, if you calculate the limit value, if you calculate the limit value, limit extends to 2 of x square, right? So when x approaches 2 from the left hand side, so if you put x equals to 1.999, so except x equal to 2, if you put x equal to 1.999, your f of x value is something about 3.999. Right? Similarly, if you put x equal to some 4.001, sorry, 2.001, then also your function value is something around 4.001. So when x approaches 2 from this side or from this side, our function value approaches only 4. Our function value approaches only 4. So here also the limit value is only 4, right? But originally the function value at 2 is 5. So limit value at 2 is 4. So when you approaches 2, the function value approaches 4. But suddenly, when you at the point x equal to 2, the function jumps to the number 5. So this is an example for a discontinuous function. Otherwise, in schools, they simply tell without lifting a pen, if you draw a graph of the curve, then it is a continuous function. Suppose if you lift the point from pen at some point and you jump somewhere, then it become a discontinuous function. Right? So this is an example for continuous function, and now I show you an example for a discontinuous function. So if a function to be continuous, the limit value should exist first, and then the function value also should exist, right? And both should be equal, right? Then there are some special cases are there. There are some functions. I'll show you. Define like this: f of x equals to x square when x not equals to 2, and it is undefined. Undefined means we don't know what is the function value. Undefined at x equals to 2. So here also, when you approach, when the limit exists, because x equal to 1.99, we know the function value is 4.9, for something around 3.99. Similarly, when x equals to 2.001, then also function value exists, because function value doesn't exist only at x equals to 2. Apart from this point, at all other points, you can able to find the function value as x square. So limit value exists. In this case also, limit value at x equals to 2 exists and is equals to 4, but unfortunately function value is not at all defined. So in that case, case also limit value exists, right? But function value is not defined, right? So for continuous function value should be defined, and then function value should be equals to the limit value, then only it is a continuous function. But these are the examples where the function fails to be continuous. Right? So now I'll give you a final example that limit itself doesn't exist. Just see one example. F of x equals to 1 by x. F of x equals to 1 by x. What is the limit? One of you please tell, what is the limit when x tends to 0 of this f of x? That is 1 by x. What is the value of 1 by x when x tends to 0? Anybody can tell? Syed, Surya. What is x value? Syed, Surya, Jonathan. What is the value of when x tends to 0? What is 1 by x? Reply. Then only you will attendance. No reply means no attendance. Whether it's correct or wrong, no problem. Jonathan, tell me. Surya, do you know? Yes or no? You just tell. Tell. Sayed,
No, sir.
you don't know what is the value of 1 by x when x tends to 0. Lejo? Anit Lejo.
Yes, sir.
Are you there in the class or not?
Yes, sir.
Then tell me, what is 1 by x when x tends to 0? I'm just typing in the screen itself. What is the value of 1 by x when limit x tends to 0? When x tends to 0, what is the value of 1 by x? When you take a number very nearer to 0, suppose 0.00001, what is the value of 1 by x? Can you tell? You can't tell, right? Because it is infinite. Right? So this is an example
Yes,
where
sir.
the limit itself doesn't exist. The limit itself doesn't exist. Right? Okay. Can you follow me? Am I audible and my video and audio is good?
Yes, sir.
Right. Right? If you have any difficulty, you can tell. Right? Okay. Okay. So now I'll tell you what is differentiation. Right? So you know limit concept, you know continuity. So limit concept, number system is base, then limit concept, then continuity. Now differentiability, because the function should be a continuous function, then only you can talk about differentiability. Right. So just now I'll tell you what is the basic definition of differentiability. Right. So usually we define differentiation like this: limit right, f dash of a, f dash of a, usually defined like this: limit x tends to a of f of x or f of minus f of a divided by x minus a. Right? So usually they define f dash of a like this: for any point a, if f of x is a function, then derivative f dash of a. So this is the definition for derivative. This is the definition for derivative. F dash of a, right? Limit x tends to a, f of x minus f of a divided by x minus a. Now try to understand, okay, what here they mean, right? Here what they mean. They mean they are finding the ratio of these two numbers. Ratio of these numbers. What they are telling, x is a number very near to a, right? So when x approaches a, what is the ratio between? Ratio between means the difference between, right, f of x minus f of a. Suppose, for example, you take a equals to 2, just like our example, and x is a number nearer to 2, you take 2.01. Then they can define f dash of a, that is f dash of 2 as f dash of 2 as limit x tends to a. So limit x tends to 2. So x is a number nearer to 2. But in our, right, so we take x as 2.01, right? So this is something like x is 2.01, right? And this is f of 2, right? And x minus a means 2.01 minus 2, that is 0.01. That is 0.01. So assume f of x as x square. The general function f of x as x square. So according to definition, what they are asking, derivative means they are simply find the ratio between these two numbers. They are asking if x is 2.01, so I want to find 2.01 square because f of x is x square minus, so this is f of x. F of x is x square, so 2.01 square minus f of 2, that is f of a. So f of a means a square, that is 2 square. So they want to find difference between these two numbers and divide these numbers by this number 0.1. So whatever number you are getting, that is the value of the derivative. That is the value of the derivative. Here you may ask, sir, where the continuity is coming? Where the continuity is coming, right? Remember, when x approaches 2, right, limit should exist. Limit should exist means whenever if you move towards 2, right, whatever number smaller, right, that number, right, should be nearer to your f of 2, right? So this limit value should approaches your function value, right? And function value also should exist. Right? But remember, 2.01 is not exactly 2. It is a number very, very nearer to 2. So then the ratio between the difference between the function values, that is f of x minus f of a, divided by difference between the x values. Remember, these two numbers are in the x-axis, these two numbers are on the y-axis. So difference between the values in the y-axis divided by difference between the values in the x-axis, this ratio they call it as the derivative of the function. Right? So usually they are finding taking any number nearer to a that they mentioned as x, and they put the value as 2.01, and there they are finding this value. Right? Now you may ask one simple question, sir. In our class school, we've already studied whenever f of x equal to x square, we know f dash of x is 2x. This we already studied in the school. But you are telling this is the ratio. How that 2x is coming, how these ratios are coming. Right? Now I will teach you, right, in general, right, how this is related with this. Because here we are generally putting 2x. But here when you put x values very nearer to 2, you get some number. How that number is equal to 2x, right? That I will teach you now. Listen carefully. If you understand this, then you can able to understand the derivative concepts. So what I told, what is f dash of a? F dash of a by concept, it is equals to limit the independent values. This is called x. So x is always called as independent variable. The variable in the x-axis is called as independent variable, and the variable in the y-axis, that is f of x, is called as dependent variable. So f of x is dependent and x is independent. Why? Because according to the x value only we can define f of x value. So x is independent and f of x is dependent. Now I can rewrite the same thing in a different manner. What I told, x is a number very nearer to a. So now I can write x is as, suppose 2.01. Suppose x is 2.01. Then 2.01 can be written as 2 plus 0.01. Right? 2 plus 0.01. So what is the meaning of this? 2 plus 0.01. We already know 2 is nothing but a value and x is 2.01. So x can be written as a, that is 2 plus some value. So x can be written as a plus h. So what is x? X is very near to a, and x can be written as a plus h, where a is fixed number, that is 2, h is a small extension, that is 0.01. So x is, so this is something like x-axis. So your a is here, that is 2, and your x is here, that is 2.01, and your h is this difference, the difference between x and a, that is h, that is 0.01. So difference between x and a is 0.01. So x, a is 2, x is 2.01. So if you move 0.01 distance from a, if you move 0.10 distance from a, you will reach a plus h, that is nothing but x, that is nothing but x, right? So now x is nothing but a plus h, or in other words you can write x minus a is equals to h. X minus a is equals to h, right? So now you just check one thing. Remember, right? Remember, x approaches a, x tends to a means x is very nearer to a. If x is very nearer to a, x minus a, that is the difference between x and a, is very very small, that is nearer to 0. It is not exactly 0, but it's very very nearer to 0, because x is a number very nearer to 0, so it is something like 2.01 or 2.0001. If you subtract that number with 2, you will get a number very nearer to 0. So here I am not putting equals to, here I am putting only implies symbol. So that means the difference between x minus a is very very small. But what is x minus a? X minus a is h. So instead of writing x minus a tends to 0, you can write the same thing as h tends to 0. H tends to 0. Now I will teach you how to rewrite everything. Now I combine all these things with the original notation. So now I can write f dash of a as limit x tends to a. X tends to a can be written as x minus a tends to 0. X minus a tends to 0 can be written as h tends to 0. So I can write this as h tends to 0. F of x. But f of x can be written as f of x can be written as a plus h. So I write a plus h in place of x minus f of a, because a no change, a is as it is. Only in place of x I am putting a plus h. Then what is x minus a? X minus a is nothing but h. X minus a is nothing but h. So I am putting h in the denominator. Right. So now I want to expand this. Now listen carefully. What is f of x? We already know f of x is x square. Throughout our problem, we simply define f of x as x square. So here f of a plus h. A plus h means it is a plus h the whole square minus this f of a, that is a square as it is. Right. So in place of f of a plus h, I am putting a plus h the whole square. In place of f of a, I put a square divided by h. Right. Now tell me, what is a plus b the whole square expansion? What is a plus b whole square expansion? Anybody? What is a plus b whole square expansion? Syed, Surya, Jonathan, Anpit. What is a plus b whole square extension? Tell me. What is a plus b whole square expansion? What is a plus b whole square expansion?
A square plus B square plus 2AB.
A square plus b square plus 2ab.
2AB.
Right? Right. A square plus b square plus 2ab. Right. So now just listen. I will once again write. So f dash of a limit h tends to 0. That is as it is. So f of a plus h can be written as a plus h the whole square, that is a square plus b square plus 2ab, right? So in place of a plus h the whole square, I'm expanding this. So this is a plus h the whole square, right? So this is a plus h the whole square. I write it as like this. Now minus a square divided by h, right? Now you just see this. This is plus a square, this is minus a square, cut it down. And what is the numerator? H square is there, plus 2a, h is there, and divided by h is there. And here limit h tends to 0, because h is a number, very small number. So we'll a number near to 0. So we write it as h tends to 0. Originally this is x minus a. Originally this is equals to x minus a. Now you can cancel out h. Then what will get finally? H plus 2a. H plus 2a. Right. Right. So now you have to apply the limit concept. What the limit says? What the limit says? H is moving towards 0. H is moving towards 0 means h is almost equals to 0. So when h moving towards 0, what will be the value, or what will h plus 2a moving? When h moves towards 0, what will be the value of h plus 2a? When h is very near to 0 or almost equals to 0, what h plus 2a approaches? Where the value h plus 2a approaches?
Infinity.
It approaches to 2a. It approaches to 2a, because this is 2a plus h is a single number and h is moving towards 0. So this is 2a plus very small number near to 0. So 2a plus this h is nothing, very near to 0. So when h approaches 0, this h plus 2a approaches 2a. Now from here only we are getting, in general, right, for the function f of x equals to x square, for the function f of x equals to x square, for general a, even though a is a fixed one, but we can put a anything. We can put a equals to 2 or a equals to 3, because a plus h the whole square formula is 2 for any a. A may be 2 or a may be 3 or a may be 4. H may be 0.1 or 0.2, what it may be. Right? So in general, for the function f of x equals to x square, for the function f of x equals to x square, I write it clearly this way. Right? For the function f of x equals to x square, your f dash of a is equals to 2a. Your f dash of a is equals to 2a. So other they write in general. So a may be any number. So I can write this as f dash of x is equals to 2x. So that in your schools you studied, for the function f of x equal to x square, the derivative is 2x. But originally what is a 2x? The 2x is nothing but the ratio of the difference between the function values. What is this number? This is the difference between the function values at a plus h and a. That is f of x minus f of a. So this is the difference between the function values divided by the difference between the values, that is x minus a, that is denoted by h. So this ratio, they call it as the derivative. That only we call it as the then only we call that function is a differentiable function, right? Since this a is true, this a may be any number, right? So this f of x equals to x square, that f dash of x equals to 2x is true for any a. We call that function is a differentiable function. We call that function is a differentiable function, and the derivative of the function is 2x, and the derivative function is 2x, right? Are you able to understand? So far, what are we discussed? Anpit, Syed, Jonathan, Surya. Can I take your attendance now? So this attendance only in between attendance. This is not end attendance, right? So you have to stay in the class till the end. and then only you have to give a final attendance also. So unpit, unpit is there? Not there. So can I put absent for unpit? Or see my screen? You are in the screen. You can see your name in the screen. Unpit. Gogolakannan is not there. Jonathan? Syed?
Present, sir. Jonathan present, sir.
Present, sir. Syed present, sir.
Syed present. Jonathan, what are you doing? You are not answering anything.
Why is it lagging, sir?
Hmm?
Your
You
voice
are
is
answering only
lagging,
for
sir.
the attendance.
Your voice is lagging, sir.
No, Syed hear me. And he also replied me also.
Sir?
Syed hear me and replied me. For you only there may be some problem. Then what about Surya? Surya also not there. Only Jonathan and Syed. Okay, for all other people I put absent. Jonathan, you have to follow. There's nothing wrong with my side, right? So because Syed is answering me. So Syed present, Jonathan present. But Surya and Lejo, I don't know what happened to them, right? But unless otherwise they're not answering my attendance, they marked absent only. Lejo and Surya marked as absent. Okay, we continue the class. So Syed, now do you know able to understand what is the derivative?
Yes, sir.
Right? So now I will tell you, right, the same thing, the same formula, right? The same methodology is followed to find the derivative of any function. Like f of x equal to x cube, f of x equal to e power x, or f of x equal to sin x or cos x, whatever it may be, the idea will be the same, right? X approaches a particular number, right? So, and then you have to find the ratio between the difference between the function values and the difference between the real numbers, right? So this ratio will gives you the derivative value. And why this derivative value? This derivative is also called as in physics, right? So physically, so mathematically we call it as derivative, but what physically it represents? It physically represents the rate of change of the independent variable, that is f of x, with respect to the rate of change of the dependent variable. What is the meaning of rate of change? Rate of change means the difference between, right? So this is called, if you write f of x minus f of a, what is the meaning, right? F of x minus f of a means what is the difference between these two numbers. Similarly, x minus a is also called as the difference between x and a, right? Where they found that difference? They are found the difference when x is very smaller, when x is very nearer to a, on a split of second, what will be the change, right? When x moves from a to a plus h in a short of period of time, what will be the change in the function value? In physics they call it as velocity, otherwise they call it as speed, right? So here you take x as per minute or per second, right? So at fifth second they were in the cover 100 meter, and then in 10th second they covered 120 meter. Then if you want to find the speed of the vehicle, what you have to do? You have to find the difference between the distance covered by the vehicle divided by time. So here the time is nothing but your independent variable. Distance depends on the time. At x is equals to 5 second, what is the distance covered? At x is equals to 10th second, what is the distance covered? Then if you find this ratio, you will get speed. So that is the rate of change of any particle, rate of change of movement. So that is a derivative. Similarly, f double dash of x is called as acceleration. That is nothing but the rate of change of velocity. How the velocity changes with respect to time, that is called acceleration. So I think there's no need to explain velocity and acceleration now in max class, because already you know the basic things like velocity, all these things. But anyway, now I just connect how the derivatives related to the physical phenomena, right? But anyway, what we need in first unit, we have partial differential equation. So now we should know what is differential equation. Then I will tell you what is partial differential equation, right? So do you know in equation, Sayed or Jonathan? Do you know? Tell me an example of an equation. Sayed, can you tell me an equation? Any equation you know? Sayed? Whether right or wrong, you just tell. Or Jonathan,
So,
any equation. Tell me an example of an equation. Then I will tell you what is differential equation.
can you come again, sir? Couldn't hear you.
Can you tell me an example of an equation? Because I can hear you in a very clear manner.
Yes, sir.
Example for an equation.
No, sir. I don't remember.
Huh?
I don't remember anything, sir.
Just tell me an equation, man. F of x equal to x square. That is an equation. X plus y equals to 10. That is an equation. Sayed,
Yes, sir.
why you are not telling? I'm just
Mic
asking,
didn't work,
tell me
sir,
an
for past 5
equation.
minutes.
Tell me an equation means you just tell it's the equation. X plus y equals to 10 is an equation.
F of x
F
is
of x
equals
equal
to
to x square is an equation, right? Then what is partial differential equation? Now I will tell you what is differential equation. Because whatever you are telling are ordinary equations, right? Now I'll tell you what is differential equation, right? So follow me. So ordinary equations, x plus y equals to 10. Then it is a ordinary equation, right? Okay. Now so what I am writing in the board?
sir.
Screen
The
is not
screen is not
visible, sir.
visible, sir.
Huh? Screen is not
Screen is
Screen is
not
visible.
not
visible.
visible.
Right, 1 minute. Okay. Can you see my screen now?
Yes, sir.
Okay. This only I am asking. dy by dx. dy by dx. Can you see the screen now?
Yes, sir. Yes, sir.
What is this? What I am writing?
dy by
By dx
dx
is
equal
equals
to
to
1.
1. What it represent? Do you know how to solve a differential equation? Do you know how to solve a differential equation? Jonathan, Sayed? Say yes or no?
No, sir.
No, sir.
Okay, right. So if you want to solve a differential equation, you have to integrate it. Very simple. Right? So what you have to do, you have to integrate this. So you have to write this as dy by dx equal to 1. You take this dx on the other side. Then you can write dy equals to dx. Right? Then you have to integration, both sides. If you integrate both sides, what do you get? Y equals to x plus integrating constant c. Do you know this thing? Jonathan Sayed.
Yes, sir.
So what I did, I just take this dx on the other side and then integrate both sides. So integral of dy is y, integral of dx is x, and whenever we integrate without limits, we have to put a constant c. Right? So now this is the ordinary equation, and this is a differential equation associated with this ordinary equation. So for any equation, you can form a differential equation of an ordinary equation, and the equation associated with the ordinary equation, the differential equation associated with this ordinary equation, right? This is called differential equation, right? But differential equation is not a separate one, right? For any differential equation, you can associate the differential equation with a ordinary equation by integrating it, right? Similarly, so this is moving from differential equations to ordinary equation. Similarly, suppose if you have an ordinary equation y equals to x plus 5, this is an ordinary equation. Can you change this as a differential equation?
Yes,
Can you
sir.
change this as a differential equation? How?
dy by dx.
You have to differentiate it. Very simple, right? So if you want to change an ordinary equation to differential equation, you have to differentiate it. If you want to change the differential equation into an ordinary equation, you have to integrate it. So if you want to form a differential equation from an ordinary equation, simply differentiate the ordinary equation. Then what do you get? Dy by dx is equals to, what do you get?
5.
Huh?
5.
Huh? If you
1, 1.
differentiate x, you will get 1. If you differentiate x plus 5 with respect to x, differentiation of x is 1.
1.
What is differentiation of constant?
0.
0. Right? So this is simply dy by dx equals to 1, and this is the equation, nothing but this equation. See? If you integrate differential equation, you get ordinary equation. But if you differentiate ordinary equation, then automatically you are getting a differential equation. So this also looks like an equation. Dy by dx is equals to 1, or this also can be written as dy by dx minus 1 is equals to 0. So this is called a first order differential equation. Why it is called first order differential equation? It is dy by dx. So it is called first order equation. Suppose it is d square by dx square, mean then become a second order differential equation, right? But one thing you understand, right? Why we are putting c here? Anybody tell? Jonathan or
Constant, sir.
why you are putting constant? When you integrate, we put one constant. Why we put? Do you know?
No, sir.
Right? So listen carefully. Right? So first thing is we transform the function from ordinary function to differential function, differential equation. So when you transform a function from ordinary function equation to differential equation, whenever we differentiate constant, what happened to constant? Constant become tell me, when you differentiate a constant, what happened? Constant become Syed, what happened to constant?
0.
Right. So when you differentiate a constant, constant becomes 0. So whether it is y equals to x plus 5 or y equal to x plus 6 or y equal to x plus 7, whatever it may be, your dy by dx is always equals to
0.
1.
1, 1, 1.
You dy by dx is also 1. So whatever may be the constant, when you differentiate it, it becomes dy by dx equals to 1. Right? So when you revert back from differential equation to ordinary equation, when you revert back from differential equation to ordinary equation, right? So when you integrate this, integrator of dy by dy is y, integral of dx is x, and then originally when you differentiate some constant, automatically it becomes 0 here. So when you revert back that constant again to the original equation, you don't know what is the value, whether it may be 5 or it may be 6 or it may be 7, whatever it may be. When you differentiate it, that number becomes 0, right? So when you revert back from differential equation to ordinary equation, right, you simply put it may be any constant c. It may be any constant c, because when y equals to x plus 5 also dy by dx equals to 1. When y equals to x plus c also dy by dx to 1. When y equals to x plus 7 also dy by dx to 1. So whatever may be the original equation, it may be of the form y equals to x plus c, y equals to x plus c. If I differentiate y equals to x plus c, I am getting dy by dx is equals to differentiating the function with respect to x. For differentiating function with respect to x means, if you differentiate x, you will get 1. And if you differentiate a constant, you will get 0. Right? So this is ordinary equation, ordinary. This is differential equation. Or simply call it as equation. So this you simply name it as equation. This is differential equation. So how to form differential equation? By differentiating the equation, you will get differential equation. How to get back to the original equation? You have to integrate. You have to integrate the differential equation. Then you can go back to your original equation. Then you can go back to your original equation. Right? So now you try to understand what is the difference between equation and differential equation. So differential equations are nothing but it is extracted from an ordinary equation. Whenever an ordinary equation is there, ordinary equation represents some moving of an object. So if you want to understand what is the velocity of the object, what is the acceleration of the object, then you have to write the equation and you have to differentiate it. One time if you differentiate, you will get the velocity of the curve. You can get the velocity of the curve, right? So that equation containing differentials like dy by dx and d square by dx square, then that equation is called as differential equation. Then the equation is called as differential equation, right? So now next class I will teach you what is partial derivative first, right? Because that is our unit 1. Partial differential equation is our unit 1. So next class I will teach you what is partial derivative, how it is different from original differentiation. Then I will tell you what is partial differential equation. What is partial differential equation? So last class and this class is something like a refreshment. From next class onwards, right, I will teach the first unit, partial derivatives, and then partial differential equation. Then I will teach